Good evening you all, I am Devanshu Kemka and this is my YouTube channel. Today we are gonna learn project 1 of NAND2TETRIS. So before moving into the NAND2TETRIS project 1, let's look into the setup. So for the setup, you're supposed to open your Google Chrome. Inside Google Chrome, search for NAND2TETRIS.org. This is the official website of NAND2TETRIS. After moving inside the website, you'll see a software page. Go inside the same, and then from the software page, download the NAND2TETRIS software suite version 2.6 and keep it in your PC. I've downloaded the same, and so here you can see I have kept it in my volume E. You can find a zip file named NAND2TETRIS.zip. You're supposed to unzip the same file, that is extract here. Once you'll extract here, you'll find a folder named NAND2TETRIS. Click on the folders, then move inside the tools. Inside the tools, if you are using Windows, go for hardware simulator.bat. If you are using Mac, you can go for hardware simulator.sh. I am using Windows, so I'll be going to hardware simulator.bat. So once I click on hardware simulator.bat, you can see the software will get open. This is the one where we'll be compiling our HDL, that is hardware demonstration language code. So let's, without wasting our time, move inside the project 1 of NAND2TETRIS. So the project 1 of NAND2TETRIS, we are gonna implement NOT, OR, AND, XOR, GATE, and MUX and DEMUX using HDL language. We'll be implementing the same in VScode. A NAND gate is something which will be need of 2 true input to get a true output. OR gate will need either 1 true input or 2 true input to get a true output. XOR gate will need odd number of true inputs to get a true output. And for a NOT gate, you'll be in need of either a true input to get a false output or a true false input to get a true input. Moving further to our multiplexer. So what is a multiplexer? A multiplexer, or MUX, is also known as a data selector, is a device that selects between several analog or digital input signals and forwards the selected input to a single output line. So as you can see, here we are having 2 input and 1 selection line, and we are just getting 1 output line. The output for the multiplexer is something not of selection line and end product of it with the input A plus of selection line end product with B input. Similarly, we can see DEMUX. DEMUX is something which is just opposite of MUX. DEMUX is something which is just opposite of multiplexer. It will be having 1 input and 2 to the power n output lines. As you can see, we are having just 1 input, and since the input was 1, the output will be 2, and we are having 1 selection line as well. The output criteria for DEMUX is in such a way that the output A will be end product of not of same selection line and A in, and the output B will be end product of selection line and A input. Let's, without wasting our time, go into the VS Code and code our gates. So here I am opening my VS Code. So once you open your VS Code, so I have created a folder named as project. Inside the project, I have kept all my 10 projects. So firstly, we're going for the project 1 in this video. Let's code our AND gate in HDL language. HDL, as I told you, it's hardware demonstration language. So the code will be inside the chip section. So let's write it up. The code which is inside the chip section, and the code is for AND gate. We'll be first taking the input. The input were A and B. Moving further to output, the output is out. The parts which will be needed for creating this gate are NAND gate and NOT gate. The NAND gate will have A input as A, B input as B, and output as none. Moving towards our next gate, that is a NOT gate. The NOT gate will have the input as NAND and the output as out. Oh, there's a minor error. Let's just save our code. Once we save our code, so let's open the simulator. Inside the simulator, you are not supposed to do anything but go into the file section, load the chip, go for the and.htl, load it, further move to load a script, go for and.txt file, load the script and run it. Once you'll run it, okay, so we can see there's a minor error. It's telling that an equal to is missing there. Let's check where the equal to is missing. Okay, you can see we have wrote out is not equals to none. Let's write it as equal to, save the file, go for NAND and run it. Select the files again, go inside the file, load chip, select n.htl file, load it, go further to your load chip. Wait, I guess there's some error when I'm loading the file. I saved it. Yeah, the end file is saved. Okay, there's a minor error again. I guess this is fine now. Let's load it up. I think I haven't saved the file. It's saved now. Okay, going to load zip. Load, yeah, it's working correct now. Go for load script. Load it. Yeah. Once you load the script and chip, just click on the run. And if it is right, it will execute successfully. Yeah, you can see the comparison ended successfully. That means our AND gate is working properly. Similarly, so here I have wrote the code for my other gates. We'll go into them one by one. So once you check for my or.htl file, the OR gate is having input as A and B, the output is out. The parts we needed for the OR gate is to NOT gate followed by AND gate and ended with the NOT gate. The first NOT gate is having an input as A, the output is not of A, the input is B, the output is not of B. The AND gate is having not of A as input A and not of B as input B, and the output is not of AB. The other NOT gate is having the input as not of AB and the output is simply out. Similarly, you can see the NOT gate. The NOT gate is having the input in and the output out. The gate we needed for this is the NAND gate. One second. So my laptop is showing me okay, so the NAND gate is having A input and B input and the output is out. Similarly, you can check of the NOT gate, you can look for the XOR gate. I'll show you my file for the XOR gate. So here you can read it. So basically you are having two inputs, the A and B, and the output is out. The parts required are one OR gate, one NAND gate followed by an AND gate. The OR gate is having the input as A and B and the output is A or B, and the NAND gate is input as A and B and the output is A and B, and the last AND gate is using the input as A or B and B NAND B and the output is the out. After this, we have wrote the code for MUX and DEMUX on the same basis. You can have a look in it. After that, we have a code for DEMUX.htl the similar way. So without wasting our time, let's implement all of them here. So we already implemented AND gate. Moving further to our OR gate, just load the chip. Once you load the chip, go for loading a script. Once you load the script for the OR.txt, you can simply run it and you'll find, I'll just increase the speed for simulation. Yes, the comparison ended successfully. That means it is working right. Moving further to our not.htl file. So here you can see loaded the chip, loaded the script for not.txt, and let's run it. Yes, it is working right as well. Moving further to our DEMUX.htl, let's load the chip, followed by loading the script for the DEMUX. Got it, it's working well. Moving further to our mux.htl. Mux is the last one, I guess. After looking for the mux, yeah, so let's run it. Oh, the comparison ended successfully. That means we have demonstrated all the code successfully. We have even reviewed the code for the AND and the other gates using different bits, which you can check in my directory. That's it for this video. Thank you for watching me. In our next video, I'll be coming up with the project 2 of NAND2TETRIS.